So in this video, let's get started with looking at first our SQL database. That's Postgres SQL database that was set up in the Google Cloud platform. We named the database FIFADB, and then we can go to the clusters, go to Jupyter Notebook, and try to run tasks one by one. And the first task we run is the data engineering, which is the task part 1. As you can see, we set up the JDBC URL as well as the driver and define that the jar that we store in the buckets. And once the session completed, it now start to read the data into the data frame, which takes a few time to run that. Okay, now the data has been written successfully to the Postgres database as well as read it successfully, and we just want to show the first 5 that we read from the database and also print out the schema. So that's the task 1. And now let's go to task 2. In task 2, we set up this same Spark as we did in task 1 and start to read the data directly from the Postgres database. And you can see the data has been successfully loaded, and we began to test it out, club with constraint, to show the result. And we work on each of the program one by one. And the second one is to show the club with the oldest player. And so the one is make a simple SQL to show the club that also the club with the oldest player for inside the task 1. And now this is for task 3 because the cluster needs to be rebooted. It doesn't have enough nodes, so I restarted the cluster, and now it's successfully run in task 3 right now. So you see, to start with, we still were able to read the data, everything from the Postgres database, process SQL, and we show the first 5 results that we have, and we begin to do some data pre-processing to set the values as well as the output. And also we will fill everything that is now and with average value. It takes a few time, and now you can see we printed out everything, and we define the pipeline to do the pre-processing and have the pipeline ran, and then we show the schema and also the first 20 rows of the processed data that we stored in the cache. And now the first machine learning model we chose was random forest, and we define the model and we run it in 20 epochs to find the best RMSE, which is to find the best arrow, the least arrow model that it has, and store it in the local as a best fit model. The validation of the root mean square takes a few times, so it runs for a long time actually. I think in data prog it kind of hide all the other runs because it's too large to display that. But basically we find the best model and then we run it against our test data, and that is the root mean square error from the test data. And another model we choose is linear regression, and we basically just print out the model we chose, and also we started to use cross-validation to find also the best root mean square error, using root mean square error to find the best model, sorry. Now we have find both the root mean square error. We find the best model for linear regression, and now we move all our data to use into pandas. So later we can use PyTorch to run against them with the same models. And the first thing is that we convert everything into pandas, and we just display the results. And we have to install PyTorch, which I have already done it in my first run, so it didn't have to install again. But basically we have to use PyTorch, install PyTorch and use it. And we just print out the shape of the train data. And now we start to run again with the random forest. Shallow neural network model. Yep, sorry. Shallow neural network, not random forest. This one takes a long time to run, especially in the cloud. But since we set up multiple nodes, working nodes for it, it's much easier and faster than my initial run. Cool, so now the 20 epochs has run successfully and we find the best model, and also we just run it against the test data set. And we do the similar thing for another deep neural network model that we defined. It also run 20 epochs against the validation set and find the best model. But yeah, that's pretty much it. Once it's finished, we'll find the best model against the validation data set, and we'll test against the test data set. And we also finished the extra credit part where we set up the postgres SQL in Google Cloud and connect it with the data proc. And yeah, as you can see earlier. So we're not storing the testing data and training data sets in the cache, but instead we store it in the database, and every time at the beginning of each task we read it from the database. Yeah, this takes a long time, but as you can see, the arrow drops significantly from the initial approach. Yep, now that's it.